Alright, so in this video, we're going to be looking at exercises 11 and 12 here. So this is not 11 through 14, it's 11 through 12 for us. So here we're supposed to determine whether the table represents a linear or a non-linear function. Okay, so how do we do this? So whenever we see a function like this, think about the line. What is a line going to have? A line is known to have a constant rate of change. That means that the slope is always going to be, the slope is going to be the same at every single point on the line, of course, right? And that's the specialty of a line. If we take a line and we decide to find the slope of it, we can always choose any points from the line and we would be fine. So that means that the change in the y over the change in the x, it needs to be constant. So let's see what I mean here. So if I go up here from 5 to 10, the change in y is positive 5, and then the change in x is positive 1. Okay, let's do this one more time. Change in x is positive 1, change in y is positive 5. So notice that even if I do this one more time, the change in y and the change in x is they're constant. So the rate of change is constant. So constant ROC, rate of change. So this is a linear function, or it's a line. This function represents a line. Linear function, or we can just say linear, but I'll just say linear function. All right, let's look at this one here. So I will need some space, so I will, let me just write it down here. So let me write this table here. Okay, so this is going to be x, and it's not very neat. This is going to be x, and this is going to be y. And so we have 5, 7, 9, 11, negative 9, negative 3, negative 1, and 3. So the rate of change on the top, so the delta x is going to be always 2 in this case, right? 2, 2, 2. Now the change in y is going to be, here it's positive 6, so plus 6. Here it's positive 2. And here it's positive 4. So notice that this is not, this does not have a constant rate of change. So if we were to say, delta y over delta x, right? So this minus this, or that would be 6 by 2. But then this minus this would be 2 by 2. So that's different. And so the rate of change, it's changing. Now if we this is our first one. Let's do this one more time. Right? Let's look at what this is happening. This is minus 4, and then plus 2. So there's something called finite differences, and using finite differences, we can actually see the power that we would have, essentially, and what type of a function we'd have. It's quadratic or linear or something like that. But in this case, we don't have to worry about that. This is non-linear. This is a non-linear function, because if someone were to ask you why, and this is a linear function, if someone were to ask you why, and you have to explain not a constant rate of change. Here we have a constant rate of change. Delta y, delta x, anywhere would be the same, at least from what's given to us. And then here for 12, delta y, so from here to here and here to here, that would be different, or here to here, here to here, then here to here, and here to here, here to here, here to here. So essentially we have different slopes at different points on the function, which means that it's not going to be a line. It's going to be some other function. It can be a parabola. It can be some other kind of function. I hope you found this video helpful.